Assalamualaikum warahmatullahi wabarakatuh. And my name is Farhan Fidos bin Ali, and my matrix number is CA210055. Today I would like to present about this methodology of this assignment. So for the first one is the library. So we run first the library, and then the second coding, which is we copy from data. Before we copy the data, we need to put the Excel data in this Google Colab, which is here, the Excel data. So after we already put, and then we copy the copy path and we paste here and we run. After we run, we print the data. So here the data. So after that we normalize the data. And then we print the normalized of the data. So here, the result of the normalized data. And then for X and Y, for X is normalized for 24 hours mean solar power from the solar panel. And then Y is same. But for X, we have the column equal to mean solar power, mean solar power. And then lastly, uh, x train equal to x value, and then we run. So for the test, we use 0.3, and the random state we use 42. So that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Al Haris bin Abdul Halim. The metric number is AE210041. Okay, for the assignment that for this assignment we use to train two model with different first layer. So for the first model, we state that the first layer is 64 and followed by the second layer is 32 and the output layer is 1. So for the activation function, we use a non-linear activation function, and the coding is ReLU. So we run this code, so it's no error. And for the epoch and the base size, we use 110 base size. That means uh we train 100 time and it's followed by 10 base size. So we run this code. It states no error. That means our training is successfully. So to get the this we use prediction for this model one, and that we plot the graph. So this is how shown the graph for the model one. That is actual versus predicted solar power output. And for the second model, we use the same coding with the model one, but we change the first layer. There is 1 to 8, and followed by second layer is 64. The activation function is still the same. It is non-linear, and the coding is ReLU. So we run this code and no error. And we made the prediction to plot the graph. So we try to plot the graph. And this is how shown the graph of the model 2 actual versus predicted solar power. The graph from the model 1 and model 2 show that not much change. There is, yeah. So that's all from me for the how we make the multi-layer neuron using the Google Colab. That's all.
Hi and Assalamualaikum. My name is Ning Arsha Balkis binti Ahmad Siddiq. So I will present my part, which is analysis and result for the coding that we have done. So based on methodology data, the MLP regression model result demonstration that both models are capable of accurate predicting solar power output. As can be seen from the graph, there is a good fit between the projected and actual value. Also, model 1 shows some variance at extreme value, including peak and falls. It nevertheless represent the generic trends. However, if you can see here, okay. However, the model 2 exhibits better accuracy and fewer line with forecasts that are smoother and more in line with the actual result. For the analysis that we did, because to design addition including more hidden layer and optimize hyperparameters, model 2 perform better than model 1. The alignment between the actual and the output suggests that this improvement probably helped to lower the error margin. Although solar power output can be predicted using either model to greater performance indicators. Uh, there is, I think, it's more suitable to capturing interaction in the data set to further reduce error rate and improve prediction accuracy. Future development might investigate a different function, regulation strategy, or assemble approach. So the result may lack completely accuracy due to several factors. The first one was maybe because of data set, the model design, and also a training process such as complexity of the model, and also the number of the layer and neurons in the model may not be enough to capture uh, non-linear pattern in the data. That's all from what I have been analysis and the result that we got. So if you can see the actual versus predicted, it's not the same as the doctor show in the class. So actually we maybe have a lacking while we do input the data value. I think that's all from me. Thank you.